Good afternoon, children. How are you? Welcome to one more fabulous session from Infinity Lane. This is Suresh, Faculty of Chemistry from Infinity Lane by Sri Chaitanya. How are you all? Good afternoon. Can you all able to see me and hear me? Just give a confirmation by thumbs up and fire emoji in the chat box. Hello. Good afternoon. Fine. That's good. That's good. Welcome to NEET STEPUP 2025 program. These particular sessions are meant for NEET 2025 program. So from afternoon 12 o'clock to evening 6 o'clock, we are providing physics, chemistry and biology sessions from Infinity Learn by Sri Chaitanya. Total syllabus of NEET is going to be covered. So please join these sessions regularly. If you could not able to join, please watch the recordings and please don't forget to like this YouTube channel and these videos, and also you please share this session with your friends and subscribe. Here Telegram channel link is also given. You please follow those. Ishita, good afternoon. Hello Vanga, good afternoon. So you're all attending these classes on a regular basis. This is really outstanding and we appreciate it. How are you all? Right, fine. Good, good, good. So these sessions, and in a week I'm chemistry teaching first 3 days of 11th syllabus and the next 3 days of a 12th syllabus. In this we are in hydrocarbons. We completed alkanes and alkenes. We are in the halfway and we are going to give a short recapture also. Devi, hello, good afternoon. And we are going to start solutions and colligative properties in tomorrow's class. So again we start with Halohydrans in the next coming 2 days session. So this is the plan for this week. So be regular in the class, right? So if you follow these lessons on a regular basis, you can complete total NEET examination syllabus. So all subjects. So these sessions are absolutely free and you can avail these by simply joining in this YouTube channel. That's it. You need not have to pay anything, are absolutely free of cost, right? So we are doing our best from our side. You please honor it and get advantage of it. Not only you, your friends also. That's why we ask you to just like, share and subscribe. What not? Hi Shiv, Amardeep, hi, Ankita Yadav, good afternoon. So Ankita Yadav, you are coming in the previous classes. Meanwhile, a couple of breaks are there. So Amarinder Singh, hi. Shiv, you are the first student. Okay, this is your first class, right? Okay, we'll start. Telegram channel is also given there. You please join in the Telegram channel, right? Sangeeta Mishra, very good afternoon. Nice to see a good gathering today. So in the previous sessions we discussed about today's class of interest is total alkenes and alkynes, right? Yes. Shiv, hi. Okay, this is your first class, right? Sangeeta, that's good. Sangeeta, I think you presented a couple of days ago and took a break, right? Devi, I think Devi you are also present in this first class. Okay, be regular so that you will get advantage of it. शिव जी स्टूडेंट्स को भी ये फायदा होगा. These sessions are intended for NEET 2025 STEPUP program जो NEET syllabus से IIT mains तक पहुंच जाएगा. So Shiv, you can attend it, you can get advantage of this, right? Okay, you watched your recording yesterday. It was energetic and fabulous session. That's good. Because of Ishita, Ishita is a regular student. She only makes me my energy at highest level. Okay, that's good. So let's talk about what we learned so far. Welcome to the session. What we learned so far here, we discussed about hydrocarbons and alkanes completed, and preparation of alkenes completed. In the preparation of alkenes, we use the major methods: dehydration of alcohols and dehydrohalogenation. And in dehydrohalogenation, you just use two rules: Sergev rule and Hoffman rule. Sergev rule says during elimination, the leaving group and the beta hydrogen should be removed. So the beta hydrogen is removed from the carbon which bears the least number of hydrogens, or the product that is formed during this process is going to be the most substituted alkene. In general, elimination follows Sergev rule. Mind it. So जब elimination आएगा ना, Sergev rule सीधा इस्तेमाल करो, बस 90% ऑफ Sergev rule का काम चलेगा. तो हाफमैन रूल क्या है? इसका उल्टा है. कौन सा कंडीशन में हाफमैन रूल आएगा? सो हाफमैन रूल मींस लेस सब्स्टिट्यूटेड अल्केन इज द प्रोडक्ट. इसका उल्टा है. सेडजफ रूल मोर सब्स्टिट्यूटेड अल्केन इज द प्रोडक्ट. हाफमैन रूल लेस सब्स्टिट्यूटेड अल्केन इज द प्रोडक्ट, है ना? सो उसमें क्या चीज है? कौन सा कंडीशन में हाफमैन रूल आना पड़ता है? ये सिंपल ट्रिक आई जस्ट वांट टू गिव यू. ओके, लर्न एक्सपेक्ट. हेलो लर्न एक्सपर्ट. इसका असली नाम क्या बेटा? यू आर एक्सपर्ट इन लर्निंग, आई एम एक्सपर्ट इन टीचिंग. सो दोनों बीच में अच्छा तरफ ट्रांसैक्शन होना चाहिए. आपका शुभ नाम क्या बेटा? ओके, सो हाफमैन रूल आप इस्तेमाल कर सकते हैं जब बेस बल्कि होना चाहिए और लिविंग ग्रुप पूर्ण लिविंग ग्रुप होना चाहिए. आर यू गेटिंग और नॉट? दिस इज अबाउट डिहाइड्रोहालोजिनेशन. हम खत्म कर लिया. इफ यू वांट टू वॉच इट अगेन, इफ यू हैव एनी डाउट, गो थ्रू द रिकॉर्डिंग एंड यू कैन कम बैक. ओके, शुभम, इतना अच्छा नाम क्या है? वेरी गुड शुभम, गुड आफ्टरनून. राइट, talking about Kolbe electrolysis भी है. Kolbe electrolysis we discussed in alkenes, फिर alkynes में आना वाला है आपका. So that physical properties and what you learn in this session, chemical reactions, hydrogenation, electrophilic additions, कल खत्म कर लिया. So Cyrus Madhav, no problem, you just attend the class. आपको पता चलेगा आज क्या होने वाले है, कैसे करने हैं. ओके, सेशन में अच्छा गैदरिंग है. सो ये अच्छा गैदरिंग में अच्छा तरफ काम भी होना चाहिए. ओके, वेरी गुड आफ्टरनून टू ऑल. राइट, सो इलेक्ट्रोफिलिक एडिशन रिएक्शंस का आज ध्यान देना. ओके, टुडे वी आर गोइंग टू सी ए बिग काइंड ऑफ क्विक रिविजन अबाउट दिस एंड आल्सो हाइड्रोक्सिलेशन एंड ओजोनोलिसिस. सो यहां तक कल कर लिया. As the students are requesting, I just want to just give a short recapture for every slide that is presented yesterday, and I want to give छोटा मोटा example भी देना चाहता हूँ. Okay, is that fine everybody? Shubham, are you ready? So let's start with chemical reactions. उसमें hydrogenation. Hydrogenation का मतलब क्या है? Addition of hydrogen, that is called hydrogenation. Hydrogenation of alkene. Ishita, fine. So for you I am just giving one more sort of recapture. You follow this, okay, you follow this and give the answer according to the questions that is given. Right, that's good. So hydrogenation means आपका देखो alkene C double bond C, when hydrogen is added, so in the presence of जो भी catalyst, प्लैटिनम इस्तेमाल कर सकते हैं आप, पलाडियम इस्तेमाल कर सकते हैं, आयरन इस्तेमाल कर सकते हैं, एनी निकल भी इस्तेमाल कर सकते हैं. ओके, सो दिस एंड दिस आर मोर प्रोमिनेंटली यूज्ड. आयरन कम इस्तेमाल करते हैं. सो दैट व्हाट हैपन, दिस हाइड्रोजन इज अटैच्ड हियर. So that I just want to give you with a color code. So that addition of hydrogen is called hydrogenation. So pi bond is removed and hydrogen is added. This is syn addition. So along with this, some amount of heat is also removed. Heat is released. A reaction, the heat is released, is called exothermic reaction. Exothermic reaction. As this is exothermic reaction, it is going to be delta H is going to be negative. सो दैट हाइड्रोजन भूल गए मैं इशिता, ओके घबराओ मत, ठीक है, वेरी गुड। सो दिस इज एक्सोथर्मिक रिएक्शन। मैं क्या बोलना चाहता हूं, ये हाइड्रोजनेशन रिएक्शन का हिसाब से ये आल्कीन का स्टेबिलिटी बोल सकते हैं ना। सो जिस आल्कीन का कम हीट ऑफ हाइड्रोजनेशन होगा वो आल्कीन ज्यादा स्टेबल होगा। सो आई जस्ट वांट टू से हियर हीट ऑफ हाइड्रोजनेशन, so the energy released when 1 mole of hydrogen is added to alkene is called heat of hydrogenation. So this heat of hydrogenation can give you the stability of alkene. So stability of alkene is inversely proportional to HOH. What is HOH, my dear students? Heat of hydrogenation. It is exothermic. So Cyrus, polar and non-polar compounds will come in chemical bonding. Chemical bonding आगे वीक में आ जाए, okay? It is of heat of hydrogenation, dear students, right? That's good. More negative का मतलब magnitude of the heat of hydrogenation, more means less is the stability. So the stability you can see here, but 1-ene, but 2-ene and but 2-ene. So ये दोनों का क्या फर्क पड़ता है? So it is cis-butene and it is a trans-butene. If you see the values here, minus 127, minus 120, minus 115. So don't look at this minus, देखना ये magnitude देखना, 127 is greater than 120 is greater than 115. So heat of hydrogenation but 1-ene का ज्यादा है, so ये कम stable है. Heat of hydrogenation trans-butene का ज्यादा है, कम है, so इसका ज्यादा stability है. So that we can say stability so stability का order trans-butene is greater than cis-butene is greater than but 1-ene. This is a very 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 important multiple choice question you can expect in NEET or JEE, कोई examination होगा. So this is the type of questions you can get it. Are you with me, right? Fine, understand, clear? Give thumbs up, fire emoji in the chat box, come on. So sometimes heat of hydrogenation निकालने का थोड़ा सा तकलीफ है क्योंकि अलग अलग alkenes अलग अलग values देते हैं. So that let us take a heat of combustion. Heat of combustion values are taken. फिर भी what is the heat of combustion? Heat released when a mole of a substance is completely burnt in oxygen, that is called heat of combustion. But heat of combustion is better than heat of hydrogenation because hydrogenation values थोड़ा उल्टा उल्टा हो सकता है, लेकिन here heat of combustion का value फिर भी है stability inversely proportional to heat of combustion. Simple. फिर मैं आपका जो values देना चाहता हूं, so please my dear students don't memorize these values. आपका एक example देके मैं demonstration देना चाहता हूं. So you don't have to worry to memorize these values. Are you getting or not? Clear, right? So heat of combustion but 1-ene, but 2-ene and trans-butene and isobutylene. इसका नाम है isobutylene. Common name है isobutylene. So ये isobutylene का, so जिस alkene का heat of combustion ज़्यादा है वो alkene कम stable है. So उसमें कम से कम value 2700, right? So ये ज़्यादा stable होगा. Isobutylene is more stable. Then 2705 trans-butene is more stable than 2710 cis-butene, then 2720 but 1-ene. So that stability 4 is greater than 3 is greater, 2 is greater 1. So like that you can do it, right? Clear children? Ishita? Very good. Shubham, any doubt here? So based on this you can get a question from any kind of examination. My dear students, आगे बढ़ो थोड़ा. Fine. Now give the products we discussed this. Okay. Electrophilic addition reaction. Electrophilic addition reaction. What is an electrophile? What is a nucleophile? Electrophile is electron seeking a group. It could be a positive charge or electron deficient. And a nucleophile, the reagent or attacking group, that attacking species which attack at a positively charged carbon is called a nucleophile. This nucleophile can be a negative charged or electron rich group. It requires a positive charge, is called nucleophile. So when you talk about, don't look at this, this is alkene. This alkene can attacked by a reagent. X plus is an electrophile, Y minus is a nucleophile. First X plus and Y minus is attacked, so that it is an addition reaction. Alkene undergo addition reaction. Always remember, a saturated compound undergo substitution reaction. Alkane undergo substitution reaction. Unsaturated compound alkene and alkyne undergo addition reaction. So here alkene undergo, we are in alkenes now, they undergo electrophilic addition reaction. In this electrophilic addition reaction, I just want to give you an example of C double bond, C, you can see C double bond C. When Br2 in the presence of CCl4 is added, what it could happen? This is a very, very important electrophilic addition reaction mechanism. सर नीट एग्जामिनेशन में, जो भी एग्जामिनेशन में मैकेनिज्म इतना काफ़ी इम्पॉर्टेंट है सर, ये मेरा सवाल है. सो इम्पॉर्टेंट मीन्स आई एम न्यूट्रल इन दैट. When you learn the mechanisms. When you attempt the examination, during learning in this Infinity Learn classes by Suresh Avari, I am going to give you certain tricks based on the mechanisms. You follow the mechanisms. So अभ्यास समय करने का वक्त में आप mechanisms कोशिश करो, okay, and when you apply the concept in the examination, you don't apply the mechanisms. Use the trick given by Suresh. This is the advice I want to give you. Clear? So Ishita, what you said is correct. So ये क्या होगा इसमें? So carbon double bond carbon, when bromine comes close to it, CCl4 is a non-polar solvent. इसका polarity बिल्कुल जीरो है. Dipole moment is absolutely zero. So that ये जो पाई बॉन्ड है ना, ये पाई बॉन्ड लूजली बॉन्डेड है. जब नेगेटिव चार्ज इस तरफ आएगा ना, इसका ऊपर जो है पॉजिटिव चार्ज डेवलप होगा, सो दैट बगल वाले को नेगेटिव चार्ज डेवलप होगा. सो दैट पॉजिटिव चार्ज का ये पाई बॉन्ड काटने का कोशिश करता है. सो दैट Br is going to be lost as Br minus. So this is Br minus बन गया, and this is going to attack by using its pi electron system. So organic chemistry सीखने का यही तरीका है बेटा. So Br, so जो pi bond है ना, that is going to form ये cyclobrominium ion. Cyclobrominium ion is the intermediate in this process. Mind it, this is very, very important. No, I am not from Maharashtra, I am from India. Okay, Sairaj, come on, let us talk about this here. So now जो बाकी Br minus है ना, this is going to attack here. So let us not discuss anybody's personal identity here. I just want to know the only name of the student, that's it. I don't ask any student here. Ishita is coming since 1 month every day. I never asked her Okay, let us not share our personal details, let us share our academic opinions, let us share our doubts, let us share and let us rise together to reach the excellence. What do you say? Madhvi? Okay, come on. So what happens? This BR want to attack, ऑलरेडी BR इज देयर ना, सो ये आगे से काटने को बहुत मुश्किल काम है क्योंकि ये ऑलरेडी प्रेजेंट ब्रोमीन रिपल्शन देता है, सो ये पीछे से काटने का कोशिश करते हैं बेटा, सो दैट इट इज ए रेयर अटैक. देयरफॉर व्हाट हैपेंस, द रिलेटेड प्रोडक्ट इज गोइंग टू बी हियर. This bromine is coming here, so that bromine here, and this bromine is attacking from this bromine here. What do you say? This is what type of attack, my dear students? My dear students, this type of attack, what do you call? Anti-addition. Anti-addition means one side and another side. This is called anti-addition. I just want to give you a simple method. Look at this particular side. If attack takes place this side and same side, this attack is called as syn attack or syn addition. If कार्बन एंड कार्बन, देखो कुछ सीखने का कोशिश करो, छोटा मोटा वाला है ना, राइट. One is attack here, another one is on the opposite side, that is called anti-attack or anti-addition. Syn and anti. You see one bromine इस तरफ है और एक दूसरा bromine the other side, so it is anti और syn. चार्ट बॉक्स में देना, चार्ट बॉक्स, come on, syn or anti, syn or anti. I want to say, my dear students, it's syn or anti. ऐसिता फायरी इमोजी का सिन और एंटी बोलना, ए वाला सिन होगा एंटी होगा. एंटी, एब्सोल्युटली करेक्ट इशिता, ग्रेट. इट इज एंटी एडिशन. एंटी एडिशन, इट इज ए स्टीरियो स्पेसिफिक रिएक्शन. व्हाट इज ए स्टीरियो स्पेसिफिक रिएक्शन? ये रिएक्शन, ये पर्टिकुलर स्टीरियो आइसोमेरिक रिएक्टेंट, रिचा शर्मा करेक्ट, a particular stereoisomeric reactant gives a particular specific stereoisomeric product. Such kind of reactions are called stereospecific reactions. Yes, addition of this. और एक चीज है ये रिएक्शन का, ये Br2 and CCl4, ये रिएक्शन में आप इस्तेमाल कर रहे हैं. Br2 is red in color. Okay, this is red in color. During this reaction, red color is going to be completely decolorized, है ना. Therefore, this is a test for alkene or alkyne. Both alkene and alkyne follows this, right? Okay, let us talk about the stereochemistry of this. So, whenever stereochemistry of this, it is a trick I just want to give. Trick I want to give by Suresh sir. ATM and car. Okay. कार में एटीएम जाके पैसा लूट के आना, सो दैट इज कॉल्ड एटीएम एंड कार. सो मजाक से बोल रहा हूं, ओके, डोंट टेक इट एज सीरियस माय डियर स्टूडेंट्स. एटीएम, एंटी एडिशन टू ट्रांसआल्कीन गिव्स मिसो प्रोडक्ट, एंड कार, सिस alkene and anti addition gives rise. Racemic mixture is very, very, very important. Here you can see एंटी एडिशन, एटीएम चीज है, एटीएम चीज है, एंटी एडिशन टू ट्रांस आल्कीन. सो ट्रांस आल्कीन मीन्स दिस इज योर ट्रांस आल्कीन, राइट, एंड सिस आल्कीन, दिस इज योर सिस आल्कीन. दिखाई दे रहा है क्या? हाँ, यस इट इज. ओके, दिस इज योर सिस आल्कीन, दिस इज योर ट्रांस आल्कीन. जब ये Br2 में करने तो क्या होगा? Br2 CCl4 में क्या होगा, यू आर गोइंग टू गेट मीसो प्रोडक्ट, सीधा मीसो प्रोडक्ट लिख सकते हैं। मीसो प्रोडक्ट का मतलब क्या, CH3 and CH3, okay, this is Br and this is Br, that's it, है ना। and why this is a meso product, क्योंकि प्लेन ऑफ सिमेट्री का वजह से दिस इज पीओएस के वजह से ये वाला मीसो प्रोडक्ट होगा। एंड सिस अल्कीन इज गोइंग टू गिव यू, टेल मी इशिता, टेल मी, Br CH3 इसका मिरर इमेज मिलेगा, so that it is going to be, it is a mirror image and this is going to be a racemic mixture, right? So cis alkene on anti addition gives racemic mixture and anti addition to trans alkene gives meso product. So Br opposite side hoga, Ishita, fine, good, nice memory, nice memory. Is all able to understand here? All able to understand here? Great. So take a snapshot of it, this 3, 2, 1. Took this? Yes. Now addition of HX. Addition of HX, it follows electrophilic addition reaction. When HX means it could be HCl or HBr, HF, HI. HF is not used in a regular basis. Why? Because fluorine का properties बिल्कुल अलग है. So Avinash, there is no chemistry. So you please, I am going to address only chemistry questions over here. Avinash, any question other than chemistry or topic related, I am going to consider this is a spam. Okay, so spamming मत करना बेटा, it's not good. We are doing, इतना मेहनत कर रहे हैं हमारी तरफ से, students also doing, sacrificing 1 year and dropping and preparing for NEET 2025. So they also have their valuable time, we also have our valuable time, right? You please respect everybody's valuable time. Anything related to chemistry, anything related to current context, only you ask a question, if any you have, right? So Avinash, welcome to the session. So HX, so what is happening when HX is added? Usme H plus X minus, H plus is added here and X minus is added here, so that you are going to get alkyl halide. Okay, so if HX could be H plus and Br minus, if this is H is added here and Br is added here. So when you add to the double bond, एक कार्बन एटम में H plus ऐड करो और इसका बगल वाले कार्बन में halogen ऐड करो. So side by side, provided that there is no rearrangement. So this follows Markovnikov rule. ये Markovnikov rule क्या है इशिता? ये Markovnikov rule है क्या? जल्दी बोलो. Right? Ishita, what is Markovnikov rule? Negative part of the reagent attaches to the carbon of double bond where it bears the least number of carbon atom. ये खतरनाक है. Markovnikov इस्तेमाल करना थोड़ा सा डेंजर है. Markovnikov रूल कहीं भी इस्तेमाल कर सकते हैं, लेकिन अगर आपका रीअरेंजमेंट होगा उसमें Markovnikov रूल नहीं चलेगा बेटा. Okay, you can see the order of reactivity of HI, yes, less substituted alkene. Okay, so HI is more reactive than HBr is more reactive than HI. So because bond energy of HI is less, जिसका बॉन्ड एनर्जी कम है उसका बॉन्ड स्ट्रेंथ भी कम होगा, ये ज्यादा रिएक्ट होगा, वो ये टेक्निक है इसमें. ठीक है, राइट. सो दैट व्हेन यू यूज इथीन, इट्स अ सिमेट्रिकल अल्कीन. आल्कीन का इस तरफ एक ही होता है सिमेट्रिकल आल्कीन। ये सिमेट्रिकल आल्कीन में सीधा HBr ऐड करो, so that you are going to get this example. This is one example और दूसरा example है। Okay, ethene, this is not ethene, it's a butene, but2ene. Okay, so when HCl is added, Hu plus here, chlorine is here, so you are going to get 2-chloro-butane is formed. 2-chloro-butane is formed. It is a symmetrical alkene. Addition to symmetrical alkene is sim. It is very easy, you can directly do it. But if you want to add unsymmetrical alkene, okay, so what happened? Addition to unsymmetrical alkene, it follows Markovnikov rule. It follows Markovnikov rule. What is Markovnikov rule? ये unsymmetrical alkene का जो है, it can be explained on the basis of Markovnikov rule, or you can explain on the basis of carbocation stability order. So Aryan, हाँ कुछ बोलना चाहता हूं क्या? Aryan, okay, spamming मत करना बेटा. So this is the particular reaction. This is the particular reaction. Propene, if Br is attacked here, this is the product. If Br is attacked here, this is the product. So which is going to be measure 1? So this is given according to a Markovnikov rule. The Markovnikov rule says here, this is Hu plus and Br minus. So this Br minus is going to attack negative part of the reagent, attacks with carbon of double bond where it has less number of hydrogens. This double bonded carbon, it has 2 hydrogens, it has 1 hydrogen, right? So this carbon has less number of hydrogens, therefore this Br minus is going to attack here. That is what you call it as Markovnikov rule is mentioned here. This Markovnikov rule, the rule states that the addition of unsymmetrical alkene reagents such as HX, H2O, HOX to unsymmetrical alkene occurs in such a way that the negative part of the reagent, carefully you see, negative part of the reagent, yes, negative part of the addendum means reagent goes to the carbon atom of the double bonded which carries less number of hydrogens. That what we have seen this. Negative part of the addendum or negative part of the reagent, right? It goes to the carbon which has less number of hydrogens. I just want to explain this by using a mechanism, the same one, one is at a major product according to Markovnikov rule. So Markovnikov rule, I just simply say it is a nickname MK rule, right? So this is going to be minor. ये कैसे ऐसा हो सकता है सर? Simply you can see this propene, वही example मैं पकड़ना चाहता हूँ, CH double bond CH2 when HBr, अब जब HBr है ना, ये ionise करके H plus Br minus होगा, right? This particular H plus is going to attack, right? So that what happened, हाइड्रोजन इस तरफ जाके ये पॉजिटिव बनेगा, हाइड्रोजन इस तरफ जाके ये पॉजिटिव बनेगा, दो चांसेस है. सो दो चांसेस I just want to write here CH3, CH and CH3 and it is going to be plus. If hydrogen goes there, I just want to make CH3 and CH2 and CH2 plus. Two types of carbocations formed. So this is carbocation A and this is carbocation B. Look at the chart box, you just tell me which carbocation is more stable, carbocation A or carbocation B. I just want to say in the chart box your opinion, A or B. Tell your opinion, come on. Either A or B. Which carbocation is more stable? Carbocation stability is tertiary is more stable than secondary is more stable than primary. है ना? Yes, you want to say A. What about Risha Sharma? Come on. Aryan, Avinash, that's good. Come on, A is more stable. Why it is more stable? Secondary carbocation, because more alpha hydrogens are there and more hyperconjugation is there, more positive inductive effect is there. So carbocation stability is explained on the basis of hyperconjugation or positive inductive effect that we discussed already in general organic chemistry. If you want to see, go through the recording that is available on the NEET YouTube channel, and you can find why this is more stable. I am telling you orally, yes, ये को वन बोल दिया, okay, कोई problem नहीं इशिता, come on, this is more stable. So a major product is always formed from more stable intermediate. सारा के सारा ऑर्गेनिक केमिस्ट्री में ये फंडामेंटल है. सो बी आर माइनस आज रिएक्ट करने तो ये वाला आपका दे देंगे CH3 CH and CH3 and it is going to be Br and this is your major product. ठीक है, and this is a less stable. So minor product is formed from the less stable one. So it is going to be CH3, CH2, CH2, Br. So this is going to be minor one. You can see the writing part over here. This is simply printed here. This is a major and this is a minor, right? So why that is minor and why this is major is indicated here. समझ में आ रही क्या? There are more than near about 500 students in the live session. Only a few students are talking to me by using chat box. Rest of the students, I recommend you please come and talk to us so that हमको भी पता चलेगा आपका doubt क्या है. Okay, talking about this is what you call so peroxide effect. वो दूसरा चीज है. Peroxide effect. When HBr is added, you can see CH3, CH double bond CH2. अगर खाली HBr ऐड करो, अभी फिलहाल ये मेजर क्या है? CH3, CH and CH3 and Br. This is your major. Okay, याद है? That's what we discussed. अभी थोड़ा सा HBr के साथ पेरोक्साइड ऐड करो. So दिस पेरोक्साइड पूरा के पूरा रिएक्शन का उल्टा करके वो दूसरा प्रोडक्ट मेजर बना सकते हैं. कैसे? देखो CH3 एंड CH2 एंड CH2 Br. इसी वक्त में ये मेजर होगा क्योंकि आप पेरोक्साइड इस्तेमाल कर रहे हैं. सो दिस इफेक्ट इज व्हाट यू कॉल इट एज peroxide effect. This peroxide effect, Ishita, you said correct. This peroxide effect first explained by a scientist called Karash. So it is also called as Karash effect. So उसमें एक चीज है very important. So students यहाँ पे गलत करने का ज्यादा संभावना है, लेकिन ये peroxide effect सिर्फ HBr के काम चलेगा. It do not work with HCl and HI. Okay, it's very important, याद रखना. Okay, so ख्याल में रखो. और एक चीज है ये वाला electrophilic addition reaction and this is a free radical addition reaction. Can you see the red color one? Electrophilic addition reaction, free radical addition reaction. Sound Ashram. Okay, we have a different YouTube session with the rank and the student, which category, which seat you are going to get, and this particular session is NEET STEPUP program. Okay, Ashran. Okay, so that I can't discuss all kind of rank versus college categories and all. Okay, so we are discussing completely with SCAIR rank 4880. Of course, that could be a very good result. Definitely you will get a government seat, but where you will get, I don't know. Definitely you will get it. In category wise you will get it, no doubt. So let us go ahead. So this is not useful for HI and HCl. Are you getting or not? Clear? Okay, आगे बढ़ना थोड़ा सा. Mechanism, it's a free radical addition mechanism. We have different methods and we all discussed these questions. You just go through the recording and you can find what is the exact answer for these questions, right? Okay, Okay, now you just retake this question. Just retake this question. I just want to ask what is the answer. I am expecting answer from my students. You just give the product of the IUPAC name of the product in the chat box. Come on, jaldi dena. हाँ, ये चीज है यहां पर, ये ओनली 1 मोल ऑफ HBr इस्तेमाल करने का कंडीशन दिया गया, सो दैट इट कैन रिएक्ट ईदर हियर और हियर. सो ख्याल में रखो, एक ट्रिक है, ये आल्कीन का पार्ट है, ये आल्काइन का पार्ट है. व्हेन आल्कीन एंड आल्काइन इज देयर, alkene is more reactive towards electrophilic addition reaction than alkyne. क्योंकि okay, anyways, why if HBr is added, H plus is added, you are going to get alkyl carbocation. अगले स्लाइड में दिखाना चाहता हूं. So this is pent 1 in 4ine. When HBr is added, H plus यहाँ पे काटने तो secondary carbocation is generated. Okay, no problem. Now this alkane अगर react करने तो दूसरा चांस है, H plus is reacted, you are going to get a vinyl carbonium ion or vinyl carbocation. This vinyl carbocation बिल्कुल unstable होगा. Therefore ये unstable का वजह से ये reaction आगे बढ़ने का मना है. Okay, आगे बढ़ने का मुश्किल है. So that this will not be formed. So that this is the only one can be formed. So Br minus is going to be reacted here. Br minus is going to be reacted here. So that you are going to get 4 bromo pent 1 ine is the product. Fine. It's very, very important. Tricky questions. These are tricky questions. These tricky questions only you are going to get in any kind of competitive examinations. ठीक है? Now let us talk about addition of HOX, formation of Halohydrin, formation of Halohydrin. So it's very, very, very important. Addition of the elements of hypohalous acids. HOX is called hypohalous acid. X is halogen, hypochlorous acid, hypobromous acid, hypoiodous acid. So this is again a tricky method. Let me finish this. When the reagent is used as X2 and H2O, so X2 means it is going to be Cl2 or it could be Br2 or it could be I2. So it is going to react with water first, it is going to give HOX and HX. In this HOX you are going to see H plus and OH minus. So it is going to give H plus and OH minus है ना. So फिर भी ये mechanism Markovnikov rule के हिसाब से होगा. So what happened here, H plus and OH minus, देखो, so it is going to be OH is attacking here and H plus is attacking here, so that halohydrin is going to be formed. Halohydrin is going to be formed. It's very, very, very important. Here I just want to give you another one. Look at this. C double bond C, it is an alkene. थोड़ा सा ध्यान दे. If we want to add Br2 in the presence of CCl4, if we want to add Br2 in the presence of H2O, solvent, here CCl4 is a solvent, Br2 is attacking, Br2 is attacking, H2O is a solvent. Solvent का वजह से आपका प्रोडक्ट बिल्कुल बदलने वाला है. So I just want to give you the product here. Look at this. The products are completely different. Yes, it is. It is first answer. That's good, Ishita. Very good, very good. that is Br and this is Br. First answer. Second answer क्या होगा? ये चीज है Br and OH. This is 1,2-dihalo and this is halohydrin. This is red color circle है ना, देखो solvent is going to change the entire fate of the reaction, है ना? Very good Ishita, very good, nice. So what is the actual mechanism? This alkene, this is the reaction, you can see this is the reaction. इसका mechanism है, पहले halogen is added, cyclohaloneum ion is formed. And the second step में OH minus is going to get anti-attack. When anti-attack takes place, halohydrin takes place. Are you getting or not? So here cyclohaloneum ion is the formation of intermediate. So intermediate formation is very important for competitive examination, and this is a trick. This is a trick that I am giving to you. Clear Ishita? लगे रहो. चलो next. और क्या? Next you can see, for example, ethene, when it is added Cl2H2O and chloroethanol is formed, ethylene chlorohydrin is a common name. So when you prepare na, this is your IUPAC name and this is your trivial name, right? Okay. Now the overall reaction involves addition of the element of hypohalous acid H and OH. उसमें H positive होगा, OH negative होगा. So that you are going to get what? Mark addition? My simplified version, MK Markovnikov rule, right, is a Russian scientist. Okay. The order of reactivity here, my dear students, chlorine in the water is more reactive than bromine in the water is more reactive than iodine in the water. Can somebody tell me the reason why? When it comes to the addition of HX, HI is more reactive than HBr is more reactive than HCl. Their bond energy does a place here, chlorine is more soluble than bromine is more soluble. Iodine is less soluble in the water, right? Now this is addition of H2O. Addition of H2O. Addition of H2O is called hydration. The hydration of alkene is of two types, indirect hydration or direct hydration. So we always study direct hydration, and let us talk about indirect hydration. NCERT में indirectly given, but directly is not given. Let us follow the indirect hydration होता है क्या? So indirect hydration के लिए you have to use cold concentrated H2SO4 or dilute H2SO4 cold condition में, okay, less than 413 Kelvin, okay, less than 413 Kelvin, right? Okay, so when you use H2, you can see H2SO4, H plus HSO4 minus. So this is, you can write this as HSO4 minus. Hydrogen bisulfate ion is a nucleophile. So first electrophile is added and ethyl hydrogen sulfate is formed. Okay? So this ethyl hydrogen sulfate, so this is further hydrolyzed. इसका importance क्या? Indirect addition में importance है क्या? So इसमें importance आता है, you will get alcohols again. So the importance, alkyl hydrogen sulfates on boiling with water undergo hydrolysis to produce alcohols. Why to boil? If you take concentrated H2SO4, so that a dehydration जो alcohol form हो चुका, ये dehydrate करने का फिर alkene आने का ज़्यादा संभावना होगा. So that to prevent that, we just indirect sulfonation, okay, then it is hydrated. So this isopropyl hydrogen sulfate, this hydrogen sulfate, if you boil with water, you are going to get its corresponding alcohols, right? So the corresponding alcohols are formed. This is indirect hydration. So indirect hydration you see again in ethers, alcohols, ethers, phenols, 12th grade, ऑर्गेनिक केमिस्ट्री पार्ट 2 एनसीईआरटी टेक्स्ट बुक सेकंड चैप्टर। ओके, सेकंड चैप्टर में जो प्रिपरेशन ऑफ ईथर्स आते हैं ना, उसमें आपको दिखाई देंगे आपको एवरी पार्ट इन द एनसीईआरटी, हाउ इट इज कनेक्टेड टू नीट और एनी कॉम्पिटिटिव एग्जामिनेशन is going to be discussed in these sessions. So you please sit in this class along with notes and a book and NCERT organic textbook, जो भी टॉपिक चल रहा है इसका हिसाब से एक टेक्स्ट बुक पकड़ के देना. So I am going to give you the reference spontaneously so that you will get every data from your textbook. Any doubts you please ask in that. Okay, that's very good. So we request this much analytic classes, you never ever get any paid sessions, but we are giving for absolute free of cost. So we request you guys, you please like these sessions and share with your friends. इन लोगों को भी फायदा होना चाहिए. So you subscribe to the channels that we are giving to you, right? Any doubt so far? So आगे बढ़ना direct hydration के लिए. Are you with me? Come on, give thumbs up, my dear students. Clear? That's good, very good, nice. Addition of H2O. Let us talk with direct hydration. It follows Markovnikov rule. It follows Markovnikov rule. So this is water. Water means it is H plus and OH minus. Now H plus is going to, OH minus is going to attack. OH minus is going to attack according to Markovnikov rule. What Markovnikov rule says? Negative part of the reagent, H plus OH minus. OH minus is the negative part of the reagent that attacks at carbon of double bond which bears less number of hydrogen. Carbon of double bond, ये कार्बन का 2 हाइड्रोजन है, ये कार्बन का 0 हाइड्रोजन है. 0 हाइड्रोजन is also a number ना. So this has a less number of hydrogens, so that OH minus, so that simply H plus should attack here. Therefore you are going to get 2-methyl prop 1 in 2 all. It follows again electrophilic addition reaction. उसमें rearrange करने के भी ज़्यादा संभावना है. अगर rearrangement होगा आपका Markovnikov rule इस्तेमाल करना मना है. So that I just want to say one example, this as without rearrangement and with rearrangement और एक देना चाहता हूँ. ठीक है बेटा? Okay, now I can give with a rearrangement. Rearrangement देना है ना? How many want to? Hi Vikas, yesterday you are there in the class? I don't know. I didn't see you, or I don't remember, or quietly you sit in the class. I am missing in your class, yeah. Richa, he is there, right? Okay. Shayad you kept quiet in the class. I don't accept that fact. Be fired. You know, you are a good student, study regularly attending and regularly interacting, but yesterday you kept quiet, huh? Okay. Let's talk about जहाँ पर rearrange. Acid catalyzed hydration may involve rearrangement, right? So this rearrangement, let us see a good example. CH3, 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 CH double bond, CH2. When you use H2SO4 and concentrated H2O here, so what could be the product? This is how people say OH here, H here, you will get an answer as a major product, but in the options that is different answer will be given. In multiple choice question, my dear students, for any competitive examination, मेरा बचपन से मैं देख रहा हूँ. So बच्चा एक आंसर सोच के देखता है ABCD ऑप्शन में, ये ऑप्शन दिखाई देगा लेकिन दूसरा का आंसर सही होगा. So take care of that. If you pass that hurdle, you will be a topper in your competitive examination. जो भी competitive examination in your lifetime, that is a secret. So सही आंसर पकड़ना कैसे? So इसका जो कॉन्सेप्ट के वजह से ये मैं मैकेनिज्म बनाना चाहता हूँ. So ये मैकेनिज्म क्या होगा? H2SO4 H plus and OH minus देना. So active reagent है CH3 and CH3, right, CH double bond CH2. So पूरा acid में है, so that H plus देते हैं. So this H plus is going to be, where is my slide? हाँ, right, it is going to attack here, so that इसका एक कार्बोकैटन बनाना कोशिश करो. So CH3 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 CH plus and CH3, राइट, ये सेकेंडरी कार्बोकैटन है. सो अच्छा तरफ मैकेनिज्म सीखने का कोशिश करो. दिस इज अ सेकेंडरी कार्बोकैटन. ओके, सो दिस इज लेस स्टेबल. This is a less stable. Can you see this? Can you see this on the board? Yes, students, right. Now what happens? This a more stable कार्बोकैटायन तरीका बनाना की कोशिश करते हैं. ये पूरा मिथाइल ग्रुप यहाँ शिफ्ट करने के बाद आपका you are going to get CH3 CH3 and CH and CH3. यहाँ जो मिथाइल ग्रुप है ना, यहाँ आके CH3 यहाँ लग गया. इसी का कारण ये वाला जो बॉन्ड है ये टूट गया. सो दिस इज गोइंग टू बी ए कार्बोकैटन. यू अंडरस्टैंड दिस? यू अंडरस्टैंड दिस? अभी ये दोनों कार्बोकैटन का स्टेबिलिटी कंपेयर करने का कोशिश करो. आंसर गलत, मिथाइल शिफ्ट है. अगर आप मिथाइल शिफ्ट नहीं कोशिश करेंगे तो आंसर गलत होने का चांसेस भी है. सो दैट it is going to be tertiary carbocation. It is a more stable carbocation. Why it is more stable carbocation? कार्बोकैटायन स्टेबिलिटी में ऐसे बोल रहा हूं, प्रीवियस सेशंस का रिकॉर्डिंग्स देखने का बोल रहा हूं मैं. सो हाइपर कॉन्जुगेशन का वजह से ये ज्यादा स्टेबल है. जो कार्बोकैटायन ज्यादा स्टेबल है ये मेजर प्रोडक्ट देने वाला है. सो दैट it is going to add with water HOH. So HOH. So the lone pair of electrons present on the water is going to act as a nucleophile, है ना? So this is a beautiful mechanism. My dear students, you never get this kind of mechanism with nice explanation in your textbooks. टेक्स्ट बुक में सिर्फ प्रिंट करके देते हैं ना, यहां पर आपका टीचर आपके सामने एक्सप्लेन करे लाइव सेशन में. सो दैट इट इज गोइंग टू गेट CH CH3 एंड CH3. नाउ वो H एंड H प्लस बन गया, राइट. नाउ दिस इज गोइंग टू लूज इट्स प्रोटॉन. प्रोटॉन इज लॉस्ट लाइक दिस. So that you are going to get a major product. You never expect this major product like this. इसका IUPAC नेम क्या? 2,3-dimethyl butane 2-ol, right? This is your major product. This is your major product. आपका माइनर प्रोडक्ट होता है क्या? ये माइनर प्रोडक्ट होता है. CH CH3 CH3 CH CH3 OH. This is your minor. Organic chemistry seems like it's so difficult and confusing. My dear students, it is easy and enjoyable if you understand. Try to understand. स्ट्रक्चर देखने का कैसा है, रिएक्शन मैकेनिज्म कैसा बनाते हैं. फर्स्ट स्टेप में क्या है, ये इलेक्ट्रोफिलिक एडिशन में H प्लस ऐड करना है, कार्बोकैटायन फॉर्म होना है, कार्बोकैटायन रीअरेंज करना है, एंड इट इज गोइंग टू ऐड विद न्यूक्लियोफाइल एंड शुड गिव द फाइनल प्रोडक्ट. एम आई राइट? मैंने माइनर लिखा था मैं. यस रीचा, इशिता, बिफोर आई स्टार्ट द मैकेनिज्म आई टोल्ड स्टूडेंट्स intentionally the answers are given in the examinations. Intentionally we solve the question, and a wrong way also give the answer. A wrong answer is one of the option. Is that fine? That's good. That's good. So wrong answer is incorporated in multiple choice questions as one of the option. Right? Bach ke रहना. Take care. Right? Now there are so many examples I want to give you for examples of acid catalyzed hydration of alkene. Right? Can you see? This is methylene cyclopentane. Let us use our own technique. Water Hu plus OH minus है ना, so that it is going to give you like this. Sometimes there is a rearrangement also. There is a rearrangement also. That's a different matter. If it is Hu plus and OH minus, Markovnikov rule, so that you are going to get the product like this. ठीक है? Yes. Yes, विकास आवाज नहीं सुन रहे? विकास. Now Hu plus and OH minus, so that कहाँ दूँ मैं? यहाँ पर, so that you are going to get a major products. So these are the major products. Dark वाला है, light वाला है, minor products है. समझ में आ रहे क्या? These are examples. These are examples. Various examples. Now, addition of water molecule we are doing in one method, that is indirect method and direct method. Direct method you have acid catalyzed hydration, and you also have two different methods. याद है? और दो methods क्या है? Anybody give me a hint so that I can start, dear children? अरे कम से कम आप भी बोल सकते हैं ना, बोलो ना, और कम से कम एक बोलो एसिड कैटालाइज्ड हाइड्रेशन के, और थोड़ा आगे बढ़ने तो और क्या मेथड इस्तेमाल कर सकते हैं? इशिता, ओके, रीचा, विकास, ओके, एनीबडी? राइट. So I can get somebody is getting the answer in the chat box. Getting the answer. Vikas, come on. So hydration of alkenes, this is one method better. अभी तक वही कर रहा हम लोग, right? And oxymercuration, demercuration और दूसरा मेथड है, and hydroboration and oxidation ये तीसरा मेथड है, right? So these are the products. Same, alkene gives alcohol, alkene gives alcohol, alkene gives alcohol, right? So ये hydration of alkenes by acid catalyzed hydration. This acid catalyzed hydration में क्या चीज है? Okay, simple remarks I just want to give you. Simple remarks. Here carbocation is formed as an intermediate. Can you see that blue color? And rearrangement is possible. Rearrangement is possible. है ना? Is that visible? Yes. And you may have to follow Markovnikov rule. You may have to follow Markovnikov rule. Oxymercuration, demercuration, you have to follow Markovnikov rule, लेकिन no rearrangement possible. No rearrangement possible. जो ट्रिक है ये ट्रिक सीधा इस्तेमाल करो, राइट? बस. एंड हाइड्रोबोरेशन ऑक्सीडेशन ये चीज है हमारा हॉलीवुड बॉक्स ऑफिस का जैसा है. हॉलीवुड बॉक्स ऑफिस नहीं है बेटा. हियर हाइड्रोबोरेशन एंड ऑक्सीडेशन, HBO, got it? HBO. Here simply give the product anti-Markovnikov rule, anti-Markovnikov addition. So you just memorize these three tricks so that you can do the best in your examination. I will give you an example. My dear students, I'll give you an example, right? Clear? Can I take a snapshot of it? 3, 2, 1, click. Okay. So let's see इसका example. CH3 and CH3 CH डबल बॉन्ड CH2, ये तीनों का जो 3 मेथड्स आप इस्तेमाल किए ना यहां पर, 1 हाइड्रेशन ऑफ alkene, okay, so hydration of alkene you can see H2SO4 and H2O. Second, oxymercuration demercuration, OMDM, right? So इसका mercuric acetate HgOAc twice and H2O in the presence of NaBH4 in the presence of NaOH bus. This is oxymercuration demercuration. First step is going to be oxidation, second step is going to be reduction. Okay, anyways, so don't go through the mechanisms here. If you go through the mechanism, you can get a stereochemistry of that also, right? And third one is going to be HBO, हमारा हॉलीवुड बॉक्स ऑफिस. हमारा हॉलीवुड बॉक्स ऑफिस में क्या? Hydroboration, oxidation. You have to use BH3 THF. You are going to get BH3 and THF and H2O2 in the presence of an alkali. So you don't have to worry. So कैसे होना, क्या होना. So मैं आपको ट्रिक दे चुका. ये ट्रिक जो है, ये ट्रिक इस्तेमाल करो. Right? So a trick है, ये एंटी मार्कोनिकॉव एंड मार्कोनिकॉव कार्बोकैटायन एडिशन, राइट? सो यहाँ पर मार्कोनिकॉव कार्बोकैटायन एंड रीअरेंजमेंट, सो दैट आपका जो प्रोडक्ट है हम फिलहाल बना चुका, सो दैट इट इज गोइंग टू बी CH3 एंड OH CH CH3 and CH3. This is your product. So there is a rearrangement. Here Markovnikov rule only use without any deviation, लेकिन उसमें no rearrangement. So बिना rearrangement करके, so CH3 and CH and CH3 and OH. See, ये दोनों प्रोडक्ट का फर्क क्या है? इशिता, you are perfectly given the correct answer, right? Now, and the third जो रिएक्शन है, सिर्फ एंटी मार्कोनिकॉव रूल इस्तेमाल करो, इसमें भी रीअरेंजमेंट ना करना, सो दैट एंटी मार्कोनिकॉव रूल के हिसाब से, सो एंटी मार्कोनिकॉव रूल जो नहीं होता है, लेकिन मार्कोनिकॉव रूल के अगेंस्ट प्रोडक्ट इज कॉल्ड एंटी मार्कोनिकॉव प्रोडक्ट. So you see the difference between these three products. एक में OH यहाँ पर था, 2 में यहाँ पर, 3 में यहाँ पर. See the beauty of chemistry here. एक reaction, molecular addition of water we are doing by using acid catalyzed and oxymercuration, demercuration, and this is hydroboration and oxidation. And my dear students, here this is the absolutely fine version of NEET examination multiple choice question. Okay, you can get the question needed answer, right? 3 methods. You all like this? You all like this? Thumbs up. You all like this? Thumbs up. Okay. Risha? Yes. Vikas? Okay. Very good. Nice. Any doubts? Now आगे बढ़ो. Okay. Now hydroxylation. Hydroxylation means two OH groups are added side by side. That is what you call it as hydroxylation. ये hydroxylation करने का three methods. One is alkenes are oxidized to 1,2-diol by using this method, beta. This method, yes, where is, yes, this method, cold alkaline aqueous potassium hydroxide and osmium tetroxide, and second one and peroxo acid. There are three methods. When you use this first method, it's very simple. When you use this first method, this cold alkaline KMnO4 is a pink color solution. When you add this pink color to solution to alkene, it is going to react, something will happen and the pink color is getting disappeared. So this cold alkaline KMnO4 decolorization or discharge of the color is a test for unsaturation that can be given to alkene and alkyne. So this cold KMnO4, pink color cold KMnO4 is called as Bayer's reagent. So this test is called as Bayer's test. Benzene do not give this test. Always memorize, benzene do not give this test. All alkenes and all alkynes give this test. Of course, cyclopropane also gives this test. ख्याल में रखो, आगे क्लास में आपको पता चलेगा बेयर स्ट्रेन थ्योरी का हिसाब से. ठीक है बेटा. And second one is osmium tetroxide. This is also gives 1,2-diol or glycol. So first alkaline cold KMnO4, osmium tetroxide or syn additions. They are going to give syn additions. So this is a syn addition and this is also syn addition. This is also your syn addition. But anti-hydroxylation takes by using a peroxide acid. This is what you call it as anti-addition. I just want to give you the best example of this. This is anti-addition. Khayal mein rakho. Stereochemistry of these reactions are very, very important. So first one is cold KMnO4. Second one is OSO4 followed by hydrolysis with Na2SO3. And the third one is peroxide acids. What is this peroxide acid? Somebody give me the just a hint. What is a peroxide acid? अरे somebody give me यार. Always I only teach is radio transmission नहीं है ना. आप भी आंसर्स दे सकते हैं. हाँ, peroxide acid जब एक कार्बोक्सिलिक एसिड में peroxo group है, that is called peroxide acid. So what do you call it as? This acid name is called acetic acid, है ना? Acetic acid. Now I just want to say ये peroxo link बना के this is what you call peroxo acetic acid. Similarly, this is PAA. My dear students, these peroxide acids are used in Baeyer-Villiger oxidation. Okay, there simply on the arrow mark acid name will be given. So by looking at the PAA, PFA, you don't have to confuse and worry, right? So what is this formic acid? Okay, this is called peroxo formic acid. So PFA, you can have benzene, peroxobenzoic acid. This is metachloroperoxobenzoic acid. This is acutely MCPBA. This term is very important. Metachloroperoxobenzoic acid, MCPBA. So of course you can use any peroxobenzoic acid also can use it. Okay, anyways, let us go ahead. So what happened? I said first Bayer's reagent, syn addition. Second, osmium tetroxide is also syn addition, and third one is anti addition, right? So let's go ahead with what is going to happen when this particular cyclohexene is treated with these three. So this is cyclohexene. So going behind this, anything you can go with hydroxylation. You will get OH here. This is called vicinal diol. This vicinal diol is a little stereo specific. So I just want to say here, look at this. You can go with these three methods. What are these three methods? Look at this. First one is called alkaline KMnO4. Okay, KMnO4 cold. Okay, in the presence of alkaline medium, right? Second one is OSO4 in the presence of osmium tetroxide, Na2SO3 hydrolysis. Third one is anti-hydroxylation, peroxo acids. You can use anything, peroxoacetic acid. You can use this. So what are the products? You don't have to worry. It is OH group and OH group to the double bond. That is a simple trick. But here syn addition. So what is the meaning of a syn addition for the first? It is going to be like this. OH, OH, H, H. So two OH groups are in the same side, it's a syn addition. Simply you can get this like this. So the product obtained in this first and the second is going to be the same. And when it comes to the third, it is going to be एंटी एडिशन. रीचा एंटी एडिशन में क्या होगा? बस जल्दी बोलो, कुछ भी ना बोलना है. हाँ, yes, Richa, correct. So it is going to be OH and it is going to be OH. So anti addition means OH on the one side and OH on the other side, right? So I just want to write the same thing here. These two are going to be syn addition products and this is going to be anti product. So this is very, very, very important. Cold alkaline, so room temperature में इस्तेमाल करना. If you just heat it ना, oxidative cleavage of carbon double bond takes place. So that's very, very important. We have to go into that. Any doubt here, children? Clear? Huh. Very good. Nice, nice, nice. Ishita, any doubt? Richa Sharma, Vikas? Come on. So today we discussed oxidation of alkene here with hydroxylation and hydration of alkenes and electrophilic addition reactions, right? In tomorrow's class, we are going to discuss about solutions on colligative properties. Today we just discussed total organic chemistry alkenes reaction and oxidative cleavage and ozonolysis bacha hua. So that we are going to discuss in Thursday class or Friday or Saturday's class. Are you getting or not? So alkenes and alkanes still thoda sa pending hai. So I think you all like my session. You please like and share and subscribe and join in the Telegram channel also. फिर मिलेंगे कल. Thank you very much. Bye bye. See you all.